Welcome to Investigation 1.3, Sliding Around. This is all about translations. So here's our focus question for this investigation, our third look at a different type of symmetry that there exists. What does it mean to say that a figure has slide or translational symmetry? How is each point related to its image under transformation by translation? So we're going to be looking at the various relationships between one image and its other if we have translated it to a new location. So a couple words worth knowing that we're going to be focusing on. First one, translational symmetry. Translational symmetry is essentially when you can slide a figure to move it to a position where it looks exactly the same as the original in its original position. So it's essentially a slide to show symmetry from an original image, to the new image. And specifically, a translation is that actual sliding. So you're taking each point and sliding it the same distance and direction to create the new image. So those are two words worth knowing that we're going to focus on with this investigation. Now on to the investigation itself. So in the investigation, we're given a shape of a hat, and that hat also has a couple of images that we're looking at it with. We're going to look specifically at this one where the hat was translated up and to the right a couple of units. And what we can notice with this translation, it asks us specifically to pay attention to to the original point and where it ends up. So looking at E to E prime, F to F prime, D to D prime, and so on. And looking how those points sort of move together. And what we'll end up noticing is every single one of those points, if you notice with those translation lines, those lines are not only parallel, the lines are parallel, but it causes each of the points, F to F prime, to move the exact same distance. So we could say essentially this distance that we have right here is the square root of 18 units, or 2 square root 3 units. So this specific situation is 2 square root 3 units. And we'd see that for E to E prime, D to D prime, B to B prime, C to C prime, and then essentially A to A prime as well. It's all the exact same distance that these particular points are moving to create the same shape further on. So if we wanted to complete a design with translational symmetry, how many images would you have to potentially make? As long as you knew where your original image and its I should do this in a different color, and its vector, in what direction you need to move it and how far, you should be able to just use two images, essentially seeing the original and the new image to see how it all translates. Based on that information, you should be able to complete a repeating design. Now on to the next point. How could we potentially draw an image under a specified translation? So we have the shape of a puppy. I was really excited about that. And we have our particular vector, or we have our particular translation that we need to make. If I look at this, I want to pay attention to how far down and how far over it's going. And it's looking like we're going down 3 units and going over 5 units. 1, 2, 3, yeah, 5 units. So every single one of my points, if I were to look at this, I'm going to erase this now so that way I have more space. So every single one of my points is going to go down 3 units and over 5. So let's start with point H. If I were to do that, I need to go down 3 units, 1, 2, 3, and over 5. 1, 2, 3, 4, 5. And that's my new H point, and that would be H prime. We're going to do the same thing with G. G's right here. It's 1 unit up from H, and so we do the same thing. We go down 1, 2, 3, and over 5 to get G prime. We do the same thing with F, E, D, C, B, J, A, and I, and finish up our little puppy here. So I'm going to do just that. Here's my I prime. Here's my J prime. A prime is 3 units over. What's kind of cool is if you already know the pattern, as you can notice from me, I'm not making any of these like down 3 over 5 sort of moves anymore. I can just know that what I'm doing based on the orientation of the points here and how they all reference this H point, I should be able to draw my translation. So I'm now going to continue. I'm going to finish this up with my point B, my point C, D, and E, and F. And I should be able to then connect my dots. It's the ultimate connect the dots, isn't it? And see my final image. And there's my puppy again. And it is that same, if I were to look at that, my H to H prime is that down 3 over 5, that same exact line. And we can see that there's a parallel to it because essentially we're having the same rise of 3 over a run of 5. So we can see that it has the same slope. This line has the same slope. And we'd also see it with I and J and A and so on. To wrap this up, let's actually look at the final drawing, and you can see that we have just that going on. So looking at our original that I created down to the one that we actually created on that Transformations app, we can see that the points all end up being the same distance and same slope away from each other. G is going to be down 3 over 5. D to D prime is going to be down 3 over 5. So we can kind of see that, and that's kind of a neat pattern, and that's our ultimate takeaway. So our slope for each point will be the same. So in this case, we have a slope of down 3 over 5. So if I were to do that, we would have a slope of negative 3/5 for every single one of my lines. And the distance between each point will be the same. So the distance between E to E prime is the exact same distance as, say, C to C prime. That's the same distance, same slope, parallel lines. It's kind of exciting. So using these ideas, work yourself through investigation 1.3 for translations. And as always, if you have any questions on how to use the angle rulers, how to use the normal rulers, do a translation, that sort of thing, make sure you please ask. Thanks so much for watching, and I will talk to you later.